Hello, and throughout the course of this video, I will be discussing the transition metals. On the periodic table, the transition metals are found in the center. Either side, you have two columns, and on the right, there's another block of elements. Combined, they're the main group, and the transition metals are in the center. The transition metals have varying properties. Most of them have all the ones I'm about to talk about now. Some may only have a few, and there are certain exceptions in some cases. So let's have a look at some of the properties they have. One of them is that they form coloured compounds, and they do this through coordination complexes. Coordination chemistry is something you'll learn about at a later date, but I thought I'd just let you know that this is how it is done. They are good conductors. Note that this is of both heat and electricity. Not all of the transition metals are good conductors of both. Some, such as titanium, is a good conductor of heat, but a poor conductor of electricity. Other metals such as copper are good conductors of both. They are malleable, which means you can hit them into shape. Another property to mention at this point is that certain metals are also what's called ductile, which means they can be drawn out into the thin wires to use in circuitry. They have high melting and boiling points. All transition metals, other than one, so there is an exception, have this property. Mercury, with the chemical symbol Hg, is actually a liquid at room temperature, therefore a low melting point and a lower boiling point. They have high densities and they are generally hard materials. Hard materials is important to note because the transition metals are tough metals, they are hard metals. Whereas if you were to look at the alkaline metals, for example, although they are a metal, they're actually really soft. If you were to take lithium, for example, you can cut lithium with a knife. They can also form a variety of different ions. An example here is with iron. You can get iron 2+ and iron 3+. Another property I would like to mention is that transition metals are what's called sonorous. So sonorous means that if you were to strike it, it would make a noise. And I'm sure you're thinking if you hit just about anything hard enough, a noise happens. If you were to tap your wooden desk, for example, you'd hear a knock. What sonorous means is if you were to hit a transition metal, the sound is prolonged. You're more likely to hear a ring as opposed to a tap. Certain chemical tests can be carried out to determine what ions are present. Something we're going to look at is distinguishing the difference between Fe2+ and Fe3+, which I showed you as an example on the previous slide. When these ions are present in an aqueous solution, they exhibit a characteristic. So, for example, starting with Fe2+, it shows a pale green or a dark green precipitate depending on the concentration of the ion present. Generally speaking, if the solution goes green, Fe2+ is likely to be present. However, if this Fe2+ lost an additional electron and turned to Fe3+, the colour completely changes. It is brown. Test result showing an orange or brown precipitate. I do apologise, I know it's just brown, I couldn't find a good enough orange. Copper 2+ is blue, and it is blue throughout. When we looked at displacement competition reactions, I showed you a solution of copper sulfate, which is very blue, which you can see here. So the testing for these ions is exposing them to a dilute amount of sodium hydroxide to give an OH- precipitate. And obviously the colours formed are these ones. So now we're going to look at some specific transition metals, their properties and their uses. So we're going to talk about, as the heading suggests, aluminium, copper and titanium. To start with, aluminium is good strength, and this is a good strength to weight ratio. It is ductile, it can be made into wires. It's a good conductor, and that is of both heat and electricity, and it's lightweight. Like I just said, the good strength is a good strength to weight ratio. It's lightweight, but it's a very tough material. It is often used in engineering aircraft because it is light but it's strong enough to withstand pressures. It can also be used as ductile, good conductor, would suggest it can also be used in electrical wiring. So taking a look at copper instead, it is malleable, it can be hit into shape, it's ductile. Copper wires are probably the most common form of wire you will get. It's corrosion resistant, and it has an attractive color, or a luster is what they call it. So a luster is, it exhibits a certain shine when it's made into things. So like I said, with the property of ductile, copper wires are a very, very common form of wire. This attractive color it has mean it's usually, you might get a copper kettle or a copper chandelier. Having a look at titanium, like aluminium, it is also very strong. It's a good conductor just of heat. It's not the best conductor of electricity. It's also corrosion resistant, just like copper, and lightweight as well. Uses of titanium can be everything from manufacturing aircraft, like aluminium is. Titanium can also be used in spacecraft engineering. Certain sporting equipment, I am aware that golf clubs, for example, use titanium. Medical implants as well as certain prosthetics. So this video has been on the properties of transition metals, talked about where they're located in the periodic table, the general properties they have, so the hard materials, high densities, good conductors. And now in this final slide we looked at some specifics, and I've mentioned some of their uses. Thank you very much for watching.